There are several methods for factoring quadratic trinomials when the leading coefficient is not 1. I'm going to cover my favorite technique. To me, this is the fastest way to find out if the quadratic is factorable or not. The key part in this method is to make sure that the GCF has been factored out. So that I call that step 0. I will go over 4 examples using this technique. So example 1. We're going to do step 0. Is there a GCF? Is there a number that goes into all 3 terms? Is there a number that goes into 6, -11, and -10? No. So we're done with step 1. Step 2. Multiply A, so A in this case is 6, by C. C in this case is -10. So we're going to multiply 6 by -10. We get -60. Now look for 2 numbers that multiply to -60 and add to B, which is -11. I like to draw an X. I put -60 up here. I put -11 down here. So it has to multiply to that and add to that. Those 2 numbers are -15 and 4. I'm going to put those here. If you're having trouble with coming up with the numbers, you just put them as pairs. These have to be integers. And you figure on the sign, one of them has to be negative in order for the product to be negative. So, and you just keep going until you get to your final answer. And that is the case. So now we're going to write 2 sets of parentheses. In both of those 2 sets, we're going to put 6x. 6x comes from here. We're going to put that into both of those. That's our AX. Then our, what I call E and F, come from our 2 factors. We're going to put those 2 over here as our second term. So -15 and +4. Now we're on our final step, which is step 4. We look within each set of parentheses and see if there is a GCF. In here, there's a GCF of 3. In the second set, 2 goes into both of them. And we're almost done. See how quick this step is? It's really nice. This technique, I mean. Okay, and that's our answer. Let's do another example using the same technique. So, step 1, as you recall, multiply A by C. In this case, 5 times, step 0. Is there a GCF? That's very important. Is there a number that goes into all 3? No, there isn't. So we go to the next step. 15. As I said before, I like to put the 15 up here. It has to multiply to that and add to B. B is 16. So the 2 numbers are 15 and 1. Write your 2 sets of parentheses. As you recall, we're going to put 5x into both. That comes from our AX. And then we're going to put 15 and 1 as our second term. That comes from the 2 numbers that multiply to 15 and add to 16. Our last step, divide by GCF if there is one. In the first set, 5 goes into both. In the second set, there is no GCF. So we're almost done. So we get x plus 3 times 5x plus 1. It's always a good idea to multiply it back to make sure you do get the same quadratic that you started out with. But if you use this technique, there's no reason to multiply back. But I just always recommend that you multiply back to make sure that you did it correctly. Next example, step 0, very important. Is there a GCF? And in this case, there is. So there is a number that goes into all 3 of them, and that number is 2. So we're going to factor that out. We're going to divide everything by that. Now we just continue. Now our new A is 4 and our C is negative 14. So we multiply those. We get negative 56. So we put that into our X. So 2 numbers that multiply to negative 56, and add to B, which in this case is negative 1. B is the number that's multiplied by X, and it's negative 1X. So the 2 numbers are negative 8 and 7. So we get our 2 sets of parentheses. We're going to put 2 in here. That 2 comes from the original 2 that was in the front to begin with when we factored out our GCF. So let's make sure that you see what we factored in here. I see that it's outside of the window. I want to make sure you see that. Well, I'll move it over here so you can see. Okay, so our 2 parentheses, remember we're going to put 4x and 4x into both. Once again, that comes from here. And then we're going to put negative 8 and 7 in the next set. So minus 8 plus 7. Last step, look for a GCF within each set of parentheses. The first one, 4 goes into both. Second one, there is nothing. We are almost done. So we have our 2. That was the original GCF that goes into everything. And now we're left with x minus 2 times 4x plus 7, and we're done. In the last example, I put that here just to show us how to tell whether something is prime or not. Prime means it's not factorable. So first step, look for a GCF. There is no GCF. I call that step 0. Then multiply A by C. That's 2 times 5, which is 10. Put 10 up here. Put 3, which is our B, down here. 2 numbers that multiply to 10 and add to 3. Now let's see, are there such 2 numbers? The integers that multiply to 10 are 1 and 10 and 2 and 5. Neither of those add up to 3. So since there are no 2 numbers, that means this quadratic is not factorable, which once again, as I said before, we call that prime. I hope you enjoyed this technique and just keep practicing.